Good morning, good afternoon, good evening, or good night, Mr. and friends. My name is Bryan Hogan, with the number 1906301305. So today, I would like to explain about fluid mechanics final project that I have done it before. So here is the presentation of final project. The first part is the abstract of the final project. Continuous high-pressure water jets currently have many industrial applications. For example, mining coal, cutting materials, and cleaning falling layers. The fluid that is used by water jet machining is water. Water jet washer is a water jet machining that used to clean a thick dirt on one spot. The water flows through a hose from the pump to the cleaning attachment with high pressure. The flow of water is divided by three types based on its Reynolds number, which is turbulent flow, laminar flow, and transition flow. Turbulent flow has Reynolds number more than 2300, laminar flow has Reynolds number less than 2000, and transition flow has Reynolds number between 2000 and 2300. So the keywords for this final project is water jet washer and Reynolds number. Next, the introduction for this final project. Water jet washer is a tool for cleaning a dust or dirt using high pressure water that controlled by a rotating bar that reverses when the water is flowing. The first water jet washer was accidentally invented by Frank Walder II in 1926 when he was working in the garage and he needed to get grease and grime off his garage floor. However, his invention remained largely unrecognized. It wasn't until Alfred Kasher in 1950 invented the first high-pressure washer and became a popular tool. So here is the water jet washer component. Water jet washer component has five main components, which is water inlet, electric motor or gas engine, water pump, high-pressure hose, and cleaning attachment. So the first part is water inlet. Here is the picture of water inlet. Water inlet is a hose that connects the pressure washer to the main water supply. There is usually a filter in the inlet to stop dirt and debris entering the washer and clogging up the works. Little bits of grit are the last thing you want inside your washer, especially since they could come blasting out of the other end at high speed. The next part is electric motor or gas engine. Most smaller pressure washers, such as the very popular ones made by Karcher, run off the domestic electricity supply, but the bigger models are powered by compact gasoline engines. The engines are similar to the one you would find in lawnmower. Typically, the power of the gasoline engines rated at around 3 until 4 kilowatt or 3.5 until 5.5 horsepower. Gas engine models are great if you are working outside in place where an electricity supply is hard to find, or where a long trailing cable would be a dangerous or inconvenient. The motor or engine is designed to power the water pump. The next component is water pump. This is the heart of pressure washer. It's a bit like a hand-operated groundwater pump, only it's driven at high speed by electric motor or gas engine instead of your hand. When the engine pulls the pump one way, it sucks water in from the faucet. When it pushes the pump the other way, the water squirts out in a high pressure jet. Pumps are designed to handle a water flow around 1 until 2 gallons per minute, or it is equals to 4 until 8 liters per minute. High pressure hose. So the high pressure hose is a tube that runs out of from the washer to whatever cleaning attachment that you have decided to use. An ordinary bit of tubing wouldn't be able to survive the high pressure of water flowing through it. High pressure hose is reinforced with wire mesh and has two or more layers of high density plastic. It's important to use hose that has a higher pressure rating than the pump in your pressure washer. But if your washer came with your own hose, there shouldn't be anything to worry about. Typically, the safety margin on pressure washer hose is about 300%. So if your washer is rated at 2000 psi, Your hose should be able to withstand the pressure of at least 6000 psi. The next part is the cleaning attachment. Depending on what you are cleaning, you can switch from a simple trigger gun, essentially just a valve that lets water through only when you squeeze the handle, to a spinning one spray or a rotating brush to scrub your drive. Powered attachments are driven by the force of the water flowing through them. Next is basic principle of water jet washer. The first step is detergent flow in from a bottle or container through one hose. The next is cold water flows in from a faucet or tap through another hose and is filtered on the way in. The third step is an electric motor or diesel engine powers the washer. The next step, powered by the engine or motor, a water pump or impeller draws in the detergent and the water and mix them together. Most washers also heat the water to a temperature of 50 until 70 degrees Celsius, or it's equal to 125 until 155 degrees Fahrenheit. The fifth step, the pump squirts out of the hot soapy water through the reinforced high pressure exit hose and whatever attachment is fixed into it. The narrow nozzle on this attachment helps to increase the pressure of the water jet even more. The high pressure of the jet not only cleans more effectively, but means you are wasting around 80% less water than if you use an ordinary low pressure hose pipe, which is more economical if your water is metered. So if we simplify it, the detergent and the water flows in from two different hoses. Next, the electric motor power the pump and mix the detergent and the cold water into the water that has higher temperature, which is from range 50 to 70 degrees Celsius. Then the mixture of the water and soap is come out from the hose and the attachment from it. The attachment usually can be used to change the pressure that we want going to use. Next, here is the objective and the method for the final project. So the objective for this final project is to know the flow type inside the water jet washer by calculate the Reynolds number. And the method for this final project is to calculate the Reynolds number by using following formula, which is Reynolds number equals to fluid density times fluid velocity times the diameter of hose divided by fluid viscosity. And the fluid that I use for this calculation is water. And here is the result. This is the water jet washer that I have at home. And from this picture, I know that the water discharge of this water jet washer is 162 liter per hour or equals to 0.0000045 meter cubic per second. And the hose diameter is 8.5 millimeter or equals to 0.0085 meter. The pressure working on this water jet washer is 35 bar or equals to 3,500,000 Pascal. And we know that the viscosity of water at 1 atmosphere is equal to 8.9 times 10 to the power of minus 4 kg per meter second. And the objective for this calculation is to find the type of the flow inside the hose. So this is the calculation that I got from the non-variable before. And the first calculation is the area of hose, which is the area of circle with the diameter of 0.0085 meter. And after I input the diameter, I got the area of hose, which is 5.6745 times 10 to the power of minus 4 meter square. Next, I calculate the water velocity, which is water discharge divided by area of hose. And I got the water velocity is 0.079 meter per second. We know that the higher the pressure, the higher the viscosity that the water has. So for the calculation of water viscosity at 3,500,000 Pascal, by calculate the pressure that I want with the known viscosity at 1 atmosphere divided by 1 atmosphere. And I got the viscosity is 0.0307 kilogram per meter second. Next, I calculate the Reynolds number, and the Reynolds number I got is 2.19. So because the Reynolds number that I got is 2.19 and it is less than 2000, so the water flow inside the hose is laminar flow. And here's the reference that I use for this final project. Thank you for listening.